Hello, we're going to do a projectile problem here that involves a quadratic equation. And let's read it first. It says a ball is thrown straight upward at an initial speed of v sub 0 equals 80 feet per second. And we're going to use the formula h equals negative 16 t squared plus v sub 0 t. And if one of our answers is not possible, we're going to enter impossible. So here are our 5 questions that are going to come from the information given to us. When does the ball initially reach a height of 64 feet? When does it reach a height of 113 feet? What is the greatest height reached by the ball? When does the ball reach the highest point of its path? And when does the ball hit the ground? First off, we're going to just look at the quadratic equation for a minute. And I'm going to actually type it into my TI calculator here. So let's type in negative 16, and I'm just going to have an x, doesn't make a difference, squared, plus v sub 0 is 80, and once again I'm going to use an x for the t. Now let's graph this and see what it looks like. I already have my ranges set and everything, and I'm going to press graph. And notice that what we get is an upside down parabola. And the reason why we get an upside down parabola is because the value of a is negative. And now, when we know what the shape looks like, it's going to help us make sense of some of the answers that we get. Notice that the y-axis is going to represent our height. The x-axis is going to represent our time. And we start off at a height of 0 because that's when you initially throw the ball. It travels up, it gets to a certain height, and it comes back down to the ground. And once again, at the end of its journey, the height is 0. Now, because it's a parabola, it's also symmetric, and every height that is on the left side is going to be duplicated on the right side as it comes back down to the ground. Now, also notice that the middle of its journey is when it reaches its maximum height, and this time here is going to be half of the total time that it takes. Now we're going to take all those factors into account when we're trying to solve all the parts of this problem. So let's go ahead and start. Part A says, when does the ball initially reach a height of 64 feet? And all we're going to do is plug the number 64 in for h. So let's do that. 64 equals negative 16 t squared plus, remember we said v sub 0 is 80 times t. Now we're looking to solve this equation for t. First thing we want to do is get it in a general form and get one side equal to 0. So we'd like to move, we have to make sure that this negative is a positive, so we want to move this term to the left, and we also want to move the 80t to the left. Now, how we're going to accomplish this is by adding 16t squared to both sides of the equation and subtracting 80t from both sides of the equation. On the left, I'm going to write out our equation. 16t squared minus 80t plus 64 equals, on the right side, all of these are going to become 0. Negative 16 squared and positive 16 squared becomes 0. 80t minus 80t becomes 0. And we have to make sure we write that down. Now, in this particular equation, all of our coefficients have a common factor of 16. So I'm going to go ahead and divide both sides of the equation by 16. 16t squared divided by 16 becomes t squared. Negative 80t divided by 16 becomes negative 5t, and 64 divided by 16 becomes positive 4. 0 divided by 16 is simply 0. Now, next up, what we're going to do, because we have a value of a of 1, we can easily factor out this equation, and we need two factors of the number 4 whose sum is negative 5. If you multiply two numbers together to get a positive and their sum is a negative, both of those factors have to be negative. So let's write out our two binomials here. I'm going to have a t there, and the two numbers that multiply to get positive 4 but add up to negative 5 are negative 1 and negative 4. We take both of these factors and set them equal to 0. So we have t minus 1 equals 0, and also t minus 4 equals 0. Now, if t minus 1 equals 0, we know that we can add 1 to both sides, and we get t equals 1. That would be seconds. If t minus 4 equals 0, we can add 4 to both sides and get t equals 4 seconds. Notice on the answer, there's only 1, and it says 1 second. Now, the reason is, let's go back to our graph here. Remember that we said this is the path that the ball will take. After 1 second, we found that it will be at a height of 64. It's going to be a little higher at 2 seconds. It's going to reach a maximum height somewhere in here, then it's going to start to come back down. So when it initially reaches 64 is after 1 second. It gets back to 64 feet after 4 seconds, but the key word here is initially, so that's why our answer is 1 second. All right, let's look at B. We're going to try to squeeze it in here on the right. It says, when does the ball reach a height of 113 feet? So let's plug in 113 for H. And I'm going to say that's equal to negative 16t squared plus 80t. We're going to do the same thing that we did before. I'm not going to write everything out. When we move negative 16t squared to the left, it becomes positive 16t squared. When we move 80t to the left, it becomes negative 80t. We also have plus 113, and we know that the right side is going to be 0. Now, the last time, all the coefficients had a common factor of 16, greatest common factor of 16. With this 113, that is not the case. So what we want to do is solve this equation here using the quadratic formula this time. So we're going to write x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and that's our quadratic formula. Now, remember that a is going to be the coefficient of the variable squared term, b is going to be the coefficient of the variable term to the first power, and c is going to be the constant. So therefore our a is 16, our b is negative 80, and c is 113. Now let's go ahead and plug in. X equals, remember to always write the negative term first, and I'm going to use the parentheses because we just said b is negative 80. Plus or minus the square root of b squared, so negative 80 squared, minus 4 times 16 times 113. All right, sorry for the small writing there. And this is all going to be over 2 times 16. So let's continue. X equals a negative and a negative become a positive. So we have 80 plus or minus. Now let's bring up our calculator again, and we're going to use that in order to figure out what the square root is. So let's get out of this. And I'm not going to take the square root yet, though, and you'll see why in just a second. Okay, so let's type in parentheses negative 80 close parentheses squared minus 4 times 16 times 113. Okay, and we get negative 832 divided by 32. Now, at this point, we can stop because the square root of a negative is going to give us a complex answer, and we're not going to get a real answer. So that's why for part B, we got impossible. There's no way that it can get to a height of 113 feet. What we have to assume is that it's not going to get up there. It's going to be the maximum height is actually going to be below 113, and we're going to see if we can figure out what that is now. Now C says what is the greatest height reached by the ball? D says when does the ball reach the highest point of its path? And E asks us when does the ball hit the ground? Okay, what we're actually going to do is work backwards a little bit. So I'm actually going to do part E first. When does the ball hit the ground? Now, if we go back to our calculator in the graph, we know that there's 2 times when the ball is on the ground. Before you throw it, of course, which is at time t equals 0. We're not interested in that. Now, the other time is somewhere over here. Now, when the ball hits the ground, the height is 0. So I'm going to plug in 0 for the height. And we're going to say 0 equals negative 16 t squared plus 80t. Okay, now we're going to solve this equation for t. What we're going to do here is take out the greatest common factor of negative 16t squared and 80t. So I'm going to write 0 equals, that is negative 16. The greatest common factor of negative 16 and 80 is a negative 16. And the greatest common factor of t squared and t is a t. So negative 16t squared divided by negative 16t is going to give us t. Positive 80t divided by negative 16t is going to give us a negative 5. Now we have 2 factors here, and once again we're going to set those 2 factors equal to 0. Negative 16t equals 0. We can divide both sides by negative 16, and that, of course, is going to yield us t equals 0. If t minus 5 equals 0 and we add 5 to both sides, we're going to get t equals 5. The 0 answer doesn't make any sense because that's before we throw the ball, so we can disregard this. But t equals 5 is when the ball hits the ground. So t equals 5, and we can look on our graph. This is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. You can see that's when the ball does indeed hit the ground. Okay, now let's work back here to D. It says, when does the ball reach the highest point of its path? Now, we just spoke about this a little while ago. If this is 5 seconds, the ball, because of the symmetric shape, is going to be at its greatest height halfway through that. So I'm going to take 5 seconds and simply divide it by 2, and 5 divided by 2 is 2.5 seconds, and we can verify that's correct. So at 2.5 seconds, the ball is at its highest point. Now we're going to go back to C. What is the greatest height reached by the ball? The greatest height reached by the ball is going to be at this value of 2.5 seconds. So for part C, what we'll do is plug in 2.5 seconds. So negative 16 times 2.5 squared plus 80 times 2.5. And let's figure that out in our calculator. We have negative 16 times 2.5 squared plus 80 times 2.5. And we see that happens at a height of 100 feet. And we can go to the calculator, we can go to the graph. If you'd like to verify this, let's see, calculate, you press second and trace, and we'd like the maximum of this shape here. Press 4, and we'll move the cursor to the left, and you can look up this process probably on another YouTube video. I'm going to press enter, and it says we want a right bound value. Enter. At guess, we press enter, and you can see that at 2.5 seconds, the maximum height is indeed 100 feet. Okay, thank you for joining us for this video.